Term project. In this project, we would like to study emergent complexity through self-organized critical systems. For this, we use two main models. First one is John Conway's game of life, and the second one is the abelian sandpile model. We simulated John Conway's game of life, and we simulated the abelian sandpile model, and we did a real-life experiment on how the abelian sandpile will be in a physical world. Game of life has some very basic rules. According to those rules, a cell can only affect itself or its closest neighbors. But what we saw is after some number of iterations later, some very complex and global patterns are arising. The second model we are studying is the abelian sandpile. It is initially created to explain what self-organized criticality is, and it is a theoretical model. We simulated that model, and in that simulation, grains are dropping onto the lattice in a pseudo-random places. Therefore, we needed to modify it a bit to make it look more like our real-life experiments. And then we made a Gaussian distributed version of it too, because we are dropping the grains onto the lattice with our cone, and the grains dropping more centrally with it, and it looks more like a Gaussian distributed. In our real-life example of the theoretical abelian sandpile, we change our granular media, and we also change the dimensionality. We use rice grains, brown rice grains, and sand grains, and we perform our experiments both in 3 and 2 dimensions. Here you are seeing an example of a 2-dimensional rice pile. We perform experiments by dropping the grains here from that cone. After the pile reached its critical height, there should be scale-free avalanches, which means that there should be no characteristic avalanche sizes. We needed to obtain those avalanche sizes to theoretically measure whether the system is self-organized critical or not. Therefore, we used an image processing method called particle image velocimetry by using a MATLAB tool called PHYS212, and we observe which granular medias and which dimensionalities show the best self-organized critical behaviors. And we saw that the best ones are the more elongated grains, which is the rice grain. And we showed that the theoretical abelian sandpile actualizes itself in a rice pile.